The number of chocolate chips in an 18-ounce bag of chocolate chip cookies is approximately normally distributed with a mean of 1,252 and a standard deviation of 129. A. What is the probability that a randomly selected bag contains between 1,100 and 1,400 chips, inclusive? So first thing we're going to do is draw a picture, and we're going to label the mean 1,252. The lower value that we're looking for is 1,100. The upper value that we are looking for is 1,400. And we were looking for the probability, so we're looking for the area under the curve, that it is between those two values. So we're looking for this shaded region here. So there are two ways of doing this. The first of which would be to find the z-scores for each. So the z-score for the lower value would be equal to 1,100 minus 1,252 divided by 129, which would be 1,100 minus 1,252 divided by 129. And we give us a z-score of negative 1.178, so 1.18. And the z-score for the higher value would be 1,400 minus 1,252 over 129, which would equal, I'm going to put this in one step by using parentheses, would be a z-score of 1.147, which would be 1.15. Now I'm going to look in a different file real quick, to find the two z-scores in our chart. So the first z-score was negative 1.18. So we're going to look here, negative 1.1. Follow this row all the way across, and going to go down here to 8. So 0.1190 is the first one. So the area to the left of this region is 0.1190. So that would represent the blue region here. Now we need to figure out the area to the left of 1.15. So if we look back over here, positive 1.15 will be on the other side. 1.1 is this row, and 5 would be in this column. 0.8749. Let's go back. So the area to the left of this is 0.8749, which would be this, we'll call this one the red region. So this area to the left would be the red region, which would include all of this value over here. So since this is included twice, we need to subtract it. We want just this area in here. So we're going to do the upper value for between area, subtract the lower from the upper, giving 0.8749 minus 0.1190, which would be 0.8749 minus 0.1190, a between area of 0.7559. Now that's with finding z-scores, excuse me, to do with the calculator. Since we know it's normally distributed, and since we're trying to find an area given two values, we can use normalcdf. We need to type in our lower value, which in this case would be 1,100. Then we need to follow that with our upper value, which would be 1,400. The mean for this question is 1,252, and the standard deviation is 129. And that should also give us 0.755 9.7550, which is what the calculator gave us, is a more accurate approximation of the value. 0.7559 has been rounded in a few instances, for instance with disease. So this is coming from the table value, and the 0.7550 was from the calculator, the TI84. Both values are within reason. Both values are pretty close to themselves. Now if we want to do part B, I'm going to use a similar procedure. I'm not going to use the z-score anymore, but we can use the same procedure to find what contains fewer than 1,100. So if we draw this picture, fewer than 1,100 would be less than 1,100. So we're going to shade this to the left. So we can just use normal CDF. Again, we're given a score. In this case, it's 1,100. We want to know less than. So we're going to have negative second E99 up to our maximum value of 1,100 because it's a less than question. Then the mean, then the standard deviation, and our answer here is 0.1193. For part C, it says what proportion of bags contain more than 1,175. More than 1,175. 1175. Well, more than question means that we're going to shade this to the right. So I'm going to change the color because we're going to go more than. So let's do to the right. So shading this to the right. Our lower shaded region, the smallest value that we want to contain is 1,175. And since the normal distribution continues infinitely, we want the largest value we can come up with as our maximum value. So we go to second vars, choose number 2 for normal CDF. Our lower value is 1175. Our upper value is going to be E99. Mean is 1,252. Standard deviation is 129. So the area to the right is 0.7247. And the last one is part D, percentile rank of a bag that contains 1,025 chips. Percentile rank is just asking for the percentage of values less than or equal to. So if we're looking for a percentile rank of 1,025, we're looking for the percentage of values that are less than 1,025 with a standard mean of 1,252 for all of these. So since we're asking for the percentile rank, we're just looking for the area to the left. So this is just going to be another lower than or less than question. Lower than 1,025 or less than 1,025. So our lower bound, oops, didn't mean to do that. Negative second comma E99. Our upper bound is the 25 that we're looking for. The mean is still 1252. The standard deviation is still 129. And this will give us that there is 0.0392 is the area to the left of our actual value that we're looking for. So the percentage of values that are to the left of this value is 0.0392. So the percentile rank is what we're looking for now. We just need to convert this into a percentage by multiplying by 100. And this would become 3.92%. However, percentile ranks always need to be written as a whole number. So this would be the 4th percentile. And that's my shorthand notation for percentile, and that's how we answer A through D.